Hello everyone. Today we will see properties of Hilbert transform. The first property is a signal x of t and its Hilbert transform x cap of t have the same magnitude spectrum or the amplitude spectrum. Here Hilbert transform is applied on the signal x of t, which is assumed to be a real valued signal. So according to this statement, we need to prove that magnitude of x of f is equal to magnitude of x cap of f. Now we know that x cap of f is equal to minus j signum function into x of f. Okay, so here if we apply magnitude on both the sides of this equation, we can write it as magnitude of x cap of f is equal to magnitude of minus j signum function into x of f. But the magnitude of minus j signum function is equal to 1. So if we substitute or replace this by 1, we get it as x of f, okay, that is equal to x cap of f. Okay, so here this becomes 1. So this will be x of f. So x of f is equal to what? Magnitude of x cap of f. Now coming to the second property, it states that if x cap of f is the Hilbert transform of x of t, then the Hilbert transform of x cap of t is minus x of t. Here the Hilbert transform is taken twice, which means that if we apply Hilbert transform on x of t, output is x cap of t, and if we apply again Hilbert transform on x cap of t, we get it as we get the answer or the output as minus x of t. So here we have a figure, we have a signal x of t, we are applying Hilbert transform on this, we get the answer or output as x cap of t. Now on this x cap of t, again we'll apply Hilbert transform and we get the output as minus x of t. So here the Hilbert transform is taken twice, then we get the answer as minus x of t. So Hilbert transform is taken twice, so here we'll multiply Hilbert transform into Hilbert transform, that is equal to minus j signum function into minus j signum function. Okay, so minus into minus is plus, j into j is j square. We get j square signum square of signum function square. So signum function square is equal to 1. We can replace this by 1. So j square is minus 1 and signum function square is 1. We get it as minus 1. And this output, it is for all the values of f. Now because the output of the above expression it is minus 1, we can say that the Hilbert transform of x cap of t, it is minus x of t. Now we'll see the third property. It states that a signal x of t and its Hilbert transform x cap of t are orthogonal over entire time interval minus infinity to plus infinity, which means that integration minus infinity to plus infinity x of t into x cap of t dt is equal to 0. That is, x of t and x cap of t are orthogonal, and if we integrate it over the time interval minus infinity to plus infinity, we get it as 0. That is, we get the value as 0. Now we know that integration from minus infinity to plus infinity x of t into x cap of t dt, it can be written as integration from minus infinity to plus infinity x of t is x of f, and x cap of t, it can be written as x cap of minus f df. Okay, so here we are taking the Hilbert transform, writing the Hilbert transform for this. Now we know that x cap of f, it can be written as minus j signum function into x of f, and x cap of minus f, it can be written as minus j signum function of minus f into x of minus f. Okay, here we'll take this minus sign minus sign from this and we'll multiply these two minus signs. Minus into minus will be plus. Then we get j as it is, signum function x of minus f. Now we will substitute these two values in this equation. So here it is integration minus infinity to plus infinity x of t, x cap of t. This x of f, it is written as it is, and x cap of minus f, it is written as j signum function x of minus f df. Okay. Now here we can rewrite this equation as minus infinity to plus infinity j signum function x of f into x of minus f can be written as magnitude of x of f whole square df. Now here in this equation, signum function, it is a odd function, and magnitude of x of f square, it is a even function. Sorry, here it should be a even function, it is not odd function. This capital X of magnitude of capital X of f whole square, it is a even function, it is not odd, it is even function. So we know that integration of an odd function over the range minus infinity to plus infinity will be equal to 0. Now here the integration is from minus infinity to plus infinity, and we have the signum function, but this signum function is a odd function. So whenever an odd function is integrated from minus infinity to plus infinity, the output will be equal to 0. So we can write it as integration from minus infinity to plus infinity x of t, x cap of t dt will be what? 0, because this term has become 0. So this whole term will be 0. So this is the orthogonal property. I hope you have understood. Just remember that this is even function. It is not odd. This is even. Signum function is odd. I hope you have enjoyed the video. Please do like the video and subscribe the channel. Thank you.